we've been trying to figure out a way that we can make it so that kids that have disabilities, but even including blindness, can create games that are highly visual in nature. And there's a couple of reasons why we want to do that. And I always have to say this first, just because that sounds like, why would you do that? Of course, a blind child's not going to make a 3D game. That doesn't make any sense. But actually, there's a couple of reasons. Number one is, again, in high school, if a kid is in a class with 3D programming, it's illegal to exclude them if it's required that they take the class. You can't do that. So that's number one. But number two as well, like I just got this hunch that if we can make that accessible, we're going to learn all sorts of weird, neat, interesting things. But so far, what we've built is we have an environment and we've tricked it to be able to be usable using technologies like screen readers, which talk to you and give you sounds related to what's in an environment. Now, how that works on a technical level is ridiculously complicated. And unless you want me to, I won't go into it. But the short and skinny is that trying to make animation loops and all this kind of stuff talk to screen readers is challenging. It took us years to figure out how to do it in such a way that it would work seamlessly. So what we have now is that we have like cameras on the screen that are in a 3D environment. There's all sorts of 3D components like boxes or spheres or things like that. So the question that I think you're getting at, Jared, is like, how does that work in terms of like what the user interface is? So like, if I have a camera and I'm looking at a 3D landscape, well, how do I describe that? And I think what we've learned so far in limited user testing and by trying it ourselves with screen readers, because we haven't finished our beta tests yet with actual blind users or other disabilities, is that so far, as far as we can tell, the most crucial thing that you want when you're talking about making 3D things accessible is actually not the gestalt, like trying to describe the whole scene at once. It's being able to know your context, which is classically called the where am I problem in disabilities work. It's sort of like, where do I exist in this environment? But in addition, being able to interact with the things that you're working with. So I'll give you an example. If I'm like building a 3D model of an ogre and I'm blind and I can't see it, I might want to know whether the ogre, which is just one model in a giant landscape, has the focus. And I might want to know that as a whole. But once I'm on the model, I might want to know things like, how many parts does this ogre have at a high level? And it might be the arms and the legs and the head. So I want to be able to query that and start to break it down. And then I want to be able to navigate those things so that I can get information about what those are. And then I can start to drill down mathematically or in some other way. So now that's not always easy. Like if you had a castle and that it had, let's just say 10 million triangles, you need to basically figure out how to combine that down into higher level items so that they can be navigated, and then allow drill downs so that you can manipulate individual pieces. And how exactly that ends up when the tool is done by, at least the first version of that part is done by the summer, will kind of be a user testing thing as we kind of try it with people. But my suspicion is that we're going to have lots of like drill down here and then go there, query the camera or query where you are around you or what's around me right now or how many things are in front of me. Stuff like that is where I suspect the direction will go as we kind of test it with people and they say, oh God, why'd you do it that way? Which is what I expect to happen the first time.
And you mentioned animation. I'm curious how you would account for describing animation when there are multiple parts going on simultaneously. Is it like different pitches or textures in the voices or?
That's a great question. Okay, so the first thing to know about animation with screen reader technologies is that making them work is like an insane challenge for reasons that have nothing to do with the user interface. And I'll describe that very briefly just to kind of give people sort of understanding. Notably, if I have in an environment like Windows uses something called the Windows message pump to get information back and forth to a computer program, right? And all this is like key presses and like mouse clicks and stuff like that. But the Windows message pump, when you're working inside of an animation library, is tied to the frame rate in certain ways, depending on how you pump it out. So think about that for a second. I get a key press, it goes on a frame, ta-da. Normally for animation, good. That's exactly how it should work. But the problem is screen reading technologies don't work that way. What they do is they get a key press and then they go through a dance with the application to try to make sure that it's querying for information at a particular time. So point being, if I press like down on the keyboard and I'm in a text editor, that might actually send back a few hundred, and I mean 100, requests to the application to gather like, where's the cursor? What is it doing? Are there any annotations here? Are there spelling errors when I'm at, or whatever it's doing, right? And so what we learned very quickly when trying to integrate an animation loop is that we have to do these like nasty equations behind the scenes to sort of force pumping in bizarre ways that don't limit the frame rate too much, although just a smidge, and that's unavoidable, but also allow it to be accessible so that you can get information back and forth to the screen reader without delays. Because if you had one request per screen reader per delay and you have a 30 frames per second, then one down arrow on the keyboard, all of a sudden you got 30 seconds until you got your little animation. So once we solved that, we then realized that if you had multiple things animating at once, you're not going to be able to understand it all at the same time. So what we then do is we have a system where you can provide information to the screen reader at strategic times. And this is done in a couple ways. One of which is that there are certain events that get fired as animations trigger that provide information to our screen reader architecture that then selectively chooses whether or not it sends information to the system. So that's number one. A good example of that would be if you press a button, you want it to click and you want the screen reader to know that. And like that is technically an animation with lots of frames doing all sorts of stuff, but the crucial information you need is the click, not the fact that it's like, flashing or whatever it's doing. And same with 3D animation too. Like if I'm rotating something, I'm not going to provide screen reader information on every step of that rotation, but I might give it only when it's done or maybe along the way or stuff like that. And those have to be kind of tuned with user testing to make sure we kind of get it right and it feels good. Normally when we use it, it's pretty easy to tell kind of when those should trigger. But then the last thing is screen readers, while they have good mechanisms for connecting into things like text editors and stuff, they just don't connect at all to 3D engines. So there's some things that we have to present to the user that don't follow a standard Windows event infrastructure. So for those, we have this little thing that we call a notify. And a notify is an event that doesn't match to an event, but forces the screen reader to talk in appropriate ways at appropriate times. And an example of that might be when I'm using a camera. One of the things we found pretty quickly is that if we try using a screen reader blind, I want to query it for all sorts of information, like where am I? What are my coordinates? What's around me? What's in front of me? What's in my frustrum? What's in my, if I zoom out, what's far, stuff like that.
Yeah.
And so the way that we do that is we use a series of accessibility notifies. They're not events, really. They give the screen reader context about a certain querying condition, and that tells the screen reader, oh, I need to find some information, and then it goes and finds it, and you're good to go. So it's really tricky. Like, it's not one thing.
Right.
It involves a series of technologies, but it's possible. You just have to be kind of judicious, and you always have to test it with people because it's real easy to get it wrong or make it just not feel good.
This excerpt was from episode 27 of the CSK8 podcast, and it was titled Accessible CS Education Through Evidence-Based Programming Languages with Andreas Stefik. You can listen to this full interview as well as hundreds more by searching for the CSK8 podcast on your favorite podcast app or by simply going to jaredoleary.com.